Hi, my name is Henry. So this is my video presentation for PSM 1. So the title for my PSM is Design of Mobility Seat for Disabled User. So let's begin with the introduction of my PSM. So here is the problem statement of my project. So the issues here, wheelchair users they usually face significant difficulty when entering or exiting the standard vehicles. And most of personal cars lack of the wheelchair access features. And moreover, the transfer often need the require of caregiver assistance, which posing a risk injury to both user and caregiver. There are some solutions to this, but these existing solutions are costly, complex, and designed for luxury vehicles only. So this is clear that we need a portable, ergonomic, and universally compatible travel system. And for this project, the solution will prioritize the user independence, comfort, and safety. So there are only two objectives of my project. The first one is to design a mechanical lift system that eases the transfer of wheelchair user, and another one is to confirm that the design lift system provides optimal safety and comfort for users. So there are two scopes. The first one is to focus on designing a mechanical lift to assist the wheelchair users entering or exiting standard vehicles. Another one is to emphasize user-centered, ergonomic, and accessible design based on vehicle dimensions. So from this project, we will get to address the key mobility challenges faced by the wheelchair users, and we can promote independence, accessibility, and dignity by enabling safer vehicle access. And lastly, we can reduce caregiver strain or encourages this greater social inclusion. So we move to the next chapter, which is the literature review. So these are the patents that are related to my project. In my report, I include 10 patents that I have searched. For this presentation, I only show you 8 of them. So as you can see, there are 7 different patents from US and 1 from China. Some of these designs are wheelchair based, and some of them are designed to transfer and lift the patient from the wheelchair into the car, and some of them are the platform for the wheelchair, which it came out and then get in back into the vehicles. This is the differences of mechanism of the patents. The first patent has the seat slide out, pivot toward the users, and then once it's slide in, it will take it back into the vehicles. And the second, the wheelchair rolls vehicles along the carriage track, and then the fixed platform is eliminated for physical transfer. Third one, the wheelchair rolls onto the side of the platform, and then the platform will lift vertically to vehicle seat level. And fourth one, it has a pivoting arm swing, and it rotates inward to place the user onto the seat, and it offers a more direct automation and compact. So fifth, it features a split seat and articulating lift arm. It allows vertical and lateral movement through the seat. And six, it supports vertical, horizontal, and rotational movement. It allows flexible transfer to vehicle seats. And second last, it uses mechanism of crank and pulley, and it is lightweight, compact, and easy to transport. Lastly, the design from China, it has an integrated seat lifting, rotation, and reclining. It can control by electric actuators for easy alignment with vehicle seats. So this is the 3 existing product visually. So the first one is called transfer percent, which is as a pivoting arm with seat, and you can put the person onto the seat and lift them from the wheelchair into the car. So the second one is car wheelchair lift. It's just a wheelchair that used to put them directly onto the vehicle, and then once they are in the wheelchair can lift out. Okay. So the last one is platform. The electric hydraulic door on wheelchair. Once the platform is out, we can put the wheelchair with the person on it directly onto the platform, and then once they are in, the platform will swing back into the vehicles. So this is the comparison table from the previous design. So the first design is vehicle mounted, second is based on a wheelchair, and the last design is vehicle mounted with hydraulic platform. So the first design required no power, it's only manual, and the second is also manual but with caregiver assistant, and lastly fully electric with hydraulic arms. So the first and second weight capacity is medium, but the last design is high because it has hydraulic and it can support more loads. So the power for the first design is vehicle power supply. Second one is required no power. The last design used the vehicle battery. So the portability for each design. The first design is fixed installation. The second is high because it has a wheel so you can move around. And lastly, the design has no portability because it's installed directly onto the car. So what is the target used for each? So the first one is personal vehicles such as sedans or SUVs. So the second design is indoor or outdoor transport. It's not only used on the vehicle, it can only use in the hospital bed or anywhere, so it can move around. And last design is vans, MPVs. This is usually designed for vehicles that are usually big. So what is the ease of introduction for each design? So the first one is moderate. Second design, the wheelchair is easy, and the last design is complex. So the first design is moderate to high user independence. The second design is low user independence. It requires the caregiver assistant. The first design is high because the design can move by itself. You can only control it by remote. So once the platform is out, the patient can lift themselves, just push themselves onto the platform, and then bring that platform back into the vehicle by remote. So this is the end for literature review. So we're moving on to the third chapter, which is methodology. So this is my project for chart. For my PSM 1, I only start with conceptual design, which the process is define problem, get information, concept generation, and lastly the evaluation of concept. And then on next semester for my PSM 2, I'm going more to do the embodiment design, which is the product architecture, configuration design, parametric design, and lastly the detail design. So there are three ways to generate conceptual design. The first one is morphological chart, proof chart selection, and lastly the pairwise comparison method. For this part, I will explain it more on the next chapter. So this is the development flowchart of my product. So first we start with literature review, and then we move to define the specification range. The first spec is load capacity, and then we have lifting height capacity. Next is portability and weight, and then we consider on the mechanical system. Second last is vehicle compatibility, and lastly the safety features. If this spec doesn't fulfill and we move again to define the specification, then once it's fulfilled, that is the end for the fulfilled specification. So next we move on to the last chapter, which is the preliminary result. So this is the conceptual design one. So over here we have the morphological chart for the first design. So the blue colored one is the option selected for this design. It has an integrated electric actuator, which is used to move uh, and adjust the reclining seat. We have a rechargeable battery unit. It is fixed within the wheelchair base. You will have a joystick and control panel on the chair. It has a motorized wheel, so you can move around. The target vehicle is universal, so you can move. You can use this on any type of vehicle, and this design is fully independent because it has a control panel and joystick to control the seat. And this is the conceptual design too. So the design for this is quite simple. It will have a motorized swivel arm. Once the arm is rotated out, the seat will automatically fold out and open, and it is tapped into the car, which use a battery or manual. The design is clamped to the door frame. It will have a button on the door panel, just beside the windows open and close buttons, and the design is detachable and compact module. And this design is only compatible on the sedans or hatchback. So this design is semi-assisted. Only use the caregiver assistant to move to lift the patient from the wheelchair onto the set only, and the rest you can control it using the control panel. So this is the last conceptual design. It has a hydraulic leader. The seat is pivoting with padded seat. It will use a manual crank or electric winch, and this design is bolted to the SUV step or frame. It has a pedal or lever for control system, and the mechanism is slide in with the hydraulic cylinder is hidden under the seat. So it is compatible on big vehicles such as SUV, four-wheel drive, and MPV. This design also semi-assisted, where we will need the caregiver assistant to put the patient from the wheelchair onto the seat. So for the next part is the criteria determination. We have two tables over here. So the first table is pairwise comparison chart. I have listed 5 different criteria, which is safety, ease of use, portability, cost, and compatibility. So I use the score from 1 to 3 only. For the same criteria, which is cross section, you can see I put the score is 1 for each criteria, which is same. And then for the most important criteria, I put them score 3, and the least important I put 1/3. So from this, we can determine the normalized matrix for each criteria, which we can see on the bottom. So we have 0.444 score. You can see it by your own. So the least value is 0.059. So move to the next one. So from the matrix table, we can determine the weightage for each criteria. The first criteria has a weightage of 37.34, which is the biggest one. And the second big is the compatibility, which has the score of 22.6. And then followed by the ease of use, which is 17.82, and then portability 12.72, and lastly the cost, which has the least score of 9.52. From this weightage, we can determine the proof chart for each conceptual design. So if the design has advantages on that criteria, I put plus score. If it's natural, I put 0. If it doesn't have that feature, so I put minus. So as you can see over here, the conceptual design one has the biggest score, which is 0.8726, and then the second design has 0.6944, and lastly the third design has 0.277. So for my project, I use the conceptual design 1 for my selection. So that is everything from me. Thank you for watching my video. And if Dr. Nick or Encik Hazifali has question on me, you can openly ask me the question.